When we talk about network data, there's obviously a very, very rich, very huge amount of data from the source address, the destination address, to the rate of traffic, to the type of messages, to the equipment used to communicate across the network. So a lot of information, and you can easily turn into information overload. So you want to keep a little bit more than what you're using so that you have some room for growth. That's my philosophy. Some of the data I look at a lot when I'm trying to kind of profile how a system has changed over time. There's some simple ones. The amount of broadcast traffic. It's a very simple metric. It's boring, but it's very revealing. Especially in a BACnet system where you don't watch it, it tends to have a lot more broadcast traffic than you want. And broadcast traffic is in general quite devastating on system performance. So tracking the amount of broadcast traffic as a basic metric can give you some indication of how the system is growing and is it leading to some problems. The second would be what devices are connected. If you're in the world of cybersecurity, you need to know what you have. But even just in the world of operations, if you have 1,000 devices today and you have 1,100 devices tomorrow, and then you trend towards 5,000, you might want to use that to take a moment and re-architect your BBMDs, your routers, and so on. The last one I would say is keeping an eye on the BBMDs, foreign devices. Those are big Achilles heel in terms of BACnet systems. They can be easily exploited from a cybersecurity standpoint. So monitoring the activity, what is communicating with the BBMD, what's coming in, what's going out. If you're able to get that level of monitoring, that can be very, very valuable. And as your broadcast traffic, as these subnets are growing, the BBMD tends to be a pretty easy place to look at that growth of the traffic. Yeah. Fantastic question. AI is so prevalent everywhere in our world now. Is it possible to use AI for anomaly detection, specifically in this case around network analytics? The short answer is absolutely. It's definitely possible, and it's going to be the future, the near future, I would say, of using artificial intelligence, machine learning to look at anomaly detection in network health. However, I should point out that AI ML requires knowing what is right and what is wrong. And based on my experience, there's a lot of wrong out there. So AI, even with self-learning and self-tuning, it might actually be tuning on the wrong set of data. So I think it definitely can be leveraged today, and it will bring value, but it will likely still on its own bring a lot of false positives or issues as we train it and give it more what is right, so it can learn from what is right to be able to identify what is wrong. I'm going to read this question literally. And predictive analytics reduce significantly emergency costs? Well, the short answer, in my opinion, is no. Most of the problems we encounter are human errors. So do you really need an advanced predictive analytics to predict human behavior? I think putting in place monitoring, old boring, what changed when, will allow us to catch most of the human errors. Give you an example, networking problem occurs because someone made a change to the network and connected two ports that were not supposed to connect and creates a loop. You can't predict that outcome, but you can detect that outcome. Just normal, old boring, continuous monitoring will allow you to catch it and identify that problem and giving you time to fix it before the technician leaves site and it doesn't become an emergency call. Very often when we think of predictive, we're thinking of something very, really, really fancy. But actually keeping an eye on the old equipment is probably the most valuable ones because they're more likely to show sign of problems before the newer equipment. It's the good old edge computing versus central computing, and there's many school of thoughts, but in general, they're all valuable. the more you can do everywhere, the earlier you can catch problems before it rises up to the top. It's just like human intelligence. If the person at the field can identify a problem, deal with it before the supervisor catches it, before the manager catches it, before the owner catches it, it's all valuable. It really just comes down to how do you implement it and what's the balance, the trade-off between cost and benefit. Analytics could be valuable, might just be more costly. So in the end, edge analytics on its own absolutely does have benefits. It really just comes down to trade-off. You use edge analytics over core analytics or a combination of both. They all bring value, and it's what is the best way to achieve your business goals, not focusing on one technology over another. It's a fantastic question. Maybe I'll answer the question a little bit differently. Where is AI and what's its place at Optigo Networks? I personally have been looking at AI for a long time. I remember playing with AI 3-4 years ago as a tool to help us write code, and it wasn't very good. It was right maybe 50% of the time. It was helpful for doing some research, but it was mostly wrong. Last year, it was incredible firsthand account of the improvement of AI engines, and now it can help you write code with very little mistakes. Now it becomes what they call prompt engineering, asking the right questions, guiding the AI engine to help you get to where you want to go. And so we are looking at AI very seriously at Optigo to transform how we work internally, but also looking at applying it to our product, our software, and provide value to our customers. I can't say much more than that at this moment. I think it's going to be very exciting. I'm very excited to look at what we can bring to the market in the next 12 months to 24 months. Of course, we want to make sure we are doing it not just for the sake of adding AI, but really actually bringing value to our customers and ourselves.